control. So we go to spot, just flip one switch and everything turns on. This was the original 10.4 device, except this had 6 outputs in it with a 10 megahertz source and a double oven source that we use, and that's all we use, portable operation. But everyone knows, what's everybody's fear about having transverters? You know, you wind up with something like this in your shack. Yeah, you know, yeah, and then your wife comes looking for, whoops, your wife comes looking, what happened to that slide? Your wife comes looking for you someday, and you're busy, because you got your friend on the phone, you're trying to figure out how to hook something up. And then she comes up with something really smart. She says, why don't you just color code everything so you know what you're doing next time? That's helpful, isn't it? It's like, who color codes their stuff? I mean, you know, brown is 6 meters, red, you know, it's like red is 2 meters. You just work right up. I mean, you know, it can't be any simpler than that. It's like color coding your rotor wires, right? Same thing. But, so let's come up here to what multiband transverter is going to look like in 2018. After one of my research and development sessions that I conducted, it's because I wasn't allowed to operate. She's in the van operating. I'm RD work. Back in about 2009, I said, well, why don't we just take one of these new A32 things and put an LO switch here and an IF switch, and then just use a 2 meter and a band selector, and this is the LO that would go to multiple bunch of transverters. So you just have one LO that's on an ovenized source and everything like this, and you can do it. And I know a lot of customers we had did this and tried to attempt this, but again, it didn't really reduce the size very much and still was kind of cumbersome and sort of like added more cables to the mix. But you had something that was a little bit more economical and a little bit more stable, so it made it very appealing. Well, one of my brainstorms was, well, we'll just make this little frequency multiplier box with a single mixer and come out of the mixer and just go through some filters and whatever stuff you want on the end. And we actually considered making this back in 2009 when I first presented this. And this got busy. And by the way, if anybody's got any questions or anything, just shout them out. This is very informal as far as I'm concerned. After all, you're eating lunch and I'm not. So just, you know. So this was a crazy idea, and I sort of attempted to do this. And yeah, in theory it works, but you know, that's what you had to do with a 1 gigahertz kind of oscillator or synthesizer. But then we did something really smart, and we sold part of the company off to a company called Q5 Signal, and they were already starting to produce this, and they approached us and they said, how do I go about selling this, and what should I do with it? This is the Digi-LO, and this one right here is a picture with the high stability reference, that little tiny 10 megahertz source on the board with this 10-turn pot to calibrate it. In case, you know, we didn't have anything open out of the bag of it, but in case someone wanted to know what it was, what it looked like. And for the people that asked if they want a custom frequency synthesizer made, it's sales@q5signal.com, and Corey will get right back to you. He's still working a day job, but he'll get back to you and help you out with whatever you need. There's still plenty of room in this bugger to put a frequency in, and if you do get we've already ordered custom frequency stuff, just burn a single frequency and then provide it to a customer. You know, it's not a big deal. And it can always be redone if you need it redone.
What PLO?
The PLO, which one's using? One of the Maxims that we're still afraid is going to disappear. But when you've done this enough times, you know, if you don't buy enough of them up front, once you're committed to it, you're hosed. So there's enough to keep this product in line for, you know, a long time right now. And as long as it doesn't become, you know, outdated because someone's making a 12 gigahertz chip, is what we're already looking at samples of. I don't know, but we got enough to make a lot of these things. So let's get back to a development of a multiband transverter. Anybody see this picture in CQ magazine that Tony came down to our shop and took? This is the inner workings and the driving force of Down East Microwave. This is where it all happens. This is where all the thought process happens. This is where all the decisions are made and how this company survives. And in case you haven't noticed, that's me standing alongside of her.
Is she the one that keeps the workbench so clean?
She demands it. She says, I'm sweeping this floor. You better make sure. Yeah. Well, no, she doesn't say that. She says, you're sweeping the floor. Right. Right. So she's also the treasurer of our local club, the Swanee Amateur Radio Club. And they don't know why she's not president because they've given her this name. She walks in the door and everybody's like, yep, 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 yep. She walks in the door and everybody goes, whoop. What are we doing tonight, Sandra? All right, so I talked to the boss and I said, we're sort of like getting to a point where we can start thinking about this multiband transverter again. And, what do bosses say? Why not? And of course, it's footnoted there when she said it. That was also requested. And, like a good subordinate, you follow the boss's plans, Okay, I've been doing that most of my life. But what are the problems? What are the issues with something that you wanted to make a wideband transverter? Well, frequency mixers, remember we had SBL1s and SBL1Xs, and we were so happy that they worked up to 1 gigahertz, 500 megahertz, and then 1 gigahertz, and we could we could have one part and we can make a couple transverters out of. Well, that's not so anymore. Wideband transmit amplifiers, remember those first mimics that gave us, oh my God, we can get a gigahertz out of it, and if we really stretch it a little bit, we can get 1296 out of it. Well, that's not so anymore. Same thing with wideband low noise amplifiers. Whoever thought they'd be making a mimic low band noise, low noise amplifier? I mean, yeah, that are actually good. I mean, like we have chips that we have a PC board company dropping on it that are half a dB at 1296. I mean, it's just phenomenal, this stuff, and it's changing every day. Here's the biggie: filters. Remember interdigital filters printed on circuit boards?
Made out of brass.
Made out of brass. Stuff we used to do. Yeah. Now when you're finding SAW filters that are 3 millimeters square, that machine drops on the board for you. So we'll go over some of that stuff. And of course, our multi-frequency oscillator. With a Digi-LO, we're good up to 6 gigahertz, and with multiplication after that, we can go higher. So the boss asked, all right, you know all this stuff, so what are the design goals? Well, the design goals were to make 2 separate transverters. A 144 to 1296 that converts HF, a 900 to 5760 that converts to VHF transverter. And this is sort of changed now. We're finding that there's no reason why this can't all be one. Well, of course, you get the next command. But, how many guys here do their best research and development this way? So I don't know what it is, it's like, and it's not like this was 10 o'clock at night, it's like, it's that mid-afternoon doze off, that little slump in there. Boom. And you get woken up and he says, well, I'm glad you enjoyed your nap, dear, but boy, if I got a surprise for you. All right, R&D. Let's get into some parts. Now, I know SDR guys aren't too interested in mixers, but you start looking at mixers that have ranges, and the only thing you're really worried about with a mixer, if you're going to make a multiband transverter with really good filters, is its port-to-port isolation, if you think about it. You don't really care what's coming back to the IF. If you're using a decent 2-meter radio or a decent 28 megahertz radio, that filter's there. It's going the other way. So if you have a good port-to-port isolation, that's a start that takes the ease off of a filter. And then you want a mixer that's simple and hand solderable. So you go to your favorite catalog in the world, yeah, and you see this, and and your jaw drops. And then you dig into the specs, and they say, well, that's the SIM series. You can pick out a frequency range within. I don't know if anybody's fallen for this. Anybody looks at this and say, oh, my God, are they really doing that? But no, they're not.
For 99 cents.
Well, yeah, you can get the 2 gigahertz mixer for like $1.50. It's yeah. No, not even that. That's the crazy part. But so it really does. It just takes a little work. You get in here and you start looking at mixer things, and of course they have the range, frequency range, and the conversion loss, which we don't care about because what Paul says, gain is cheap. We're only worried about LO to RF isolation specs, and they give you these, low range, mid range, upper range. So you sort of have to decipher that, and then you also have to look at how they spec it, what the LO to RF isolation. LO to RF frequency separation is. And most of the time they do it at 30 megahertz, which is kind of helpful if you're doing a 28 megahertz design. But, it's just a matter of digging in and looking around. And as I said, it's port-to-port isolation. So here's one in particular that we're very, very fond of. And it's 100 pieces at like $9 a piece. But, it covers the band. Again, you look at the typical port LO to port isolation, and you have to dig into the real specs. And they give you this, and again, the LO to RF separation. And you start looking at the isolation specs, of course, way down low, it's great. And then it gets a little iffy in the middle here, and then as we get to the top, it starts getting good again. I don't know how, what causes that to happen. You would think it would just taper all the way off bad to the end, but it gets good to the end. But that's the design. And there's other designs out, but we're sort of mini circuits fans because once they make something and they put it on the market, they promise not to take it off the market. So you're kind of good to use it, especially if you're a manufacturer. So our research says we're gonna go about doing this, and of course we looked at everybody. Even passive and active mixes. Anybody heard of this company here in North Carolina? If you ever get a chance to talk to these dudes, they're wild. What do you want to do? Man, that's wild. You're kidding me. They're always excited and to want to talk to you. They say, yeah, we can tune that up for you. But they make these 1.5 mil square chips, either LNAs or power amplifiers, and they give you the range as well. This will work between 1 and 8 gigahertz without any problem, but they have specific little tuning ranges that they work really good in, and then outside of those tuning ranges, they just work. But we can tune this up, we can do this, and they came to me with this VHF through 10 gigahertz version where it had like 45 dB gain at 2 meters and 15 dB gain at 10 gigahertz. And I said, can you flatten that out a little bit? And they said, no. So, that's kind of like where we are. But, they do actually make active mixers and with either gain stages on the LO side if you need it and on the RF side or IF side, just like mini circuits most of the companies do. All right, we're going to transmit amplifiers. So what's the important factor of a transmit amplifier when you want it to work that range? You want some flatness. You don't want it to be, as I just mentioned, 25 dB gain at 2 meters and 8 dB gain at 6 gigahertz. That's kind of, what are you going to do when you run out of power at the 6 gigahertz range if you have a multiband transverter where you're going to set the IF drive level once and walk away from it? So that's the important part. You also want some useful output power. 100 milliwatts is kind of handy to have around. And it'd be really helpful that after you blew this up, you'd be able to solder it and fix it yourself. So design issues. You start looking at data sheets, the mimics are specified for wide bandwidth operation. Yeah, we got this mimic that works between 500 and 8 gigahertz, but most require special tuning to optimize it, again, as I just discussed. A transverter like this needs about 25 dB gain, so if you need 2 of them, that's not a big deal, as long as they both work the same. What kind of gain slope spec? Well, is 2 dB enough? If you have 20 dBm at the VHF and it slopes down to 18 dBm. You know, is that good enough to get the job done? Then you find out that some are not hand solderable and some are not very economical. So what do I mean by gain slope? Well, here's your MAR3. You look at a sheet at 112.5 dB gain and it slopes to 2 gigahertz. Of course, this is a bad example for a wideband, but that's just to give you an idea how they spec things out. 100 megahertz, 1 gig, 2 gig. Let's look at a PHA-1. Who uses PHA-1s in their stuff around here? It's really popular. And they say it was supposed to be good to 6 gigahertz, but it's 17 dB gain at 50 megs, and it's less than 10 dB gain at 6 gigahertz, so it's not a real good candidate for the job. And you keep looking, you look around. So, well, look at this guy here, 21, 21, 14. Well, you know, maybe you could live with that. And you start finding out why they spec these things at. And they got little special tuning circuits in here. This is what you got to do if you want it to work optimally at this frequency, but this part does work 250 to 400 megahertz. So you have to weed that stuff out. You have to find that stuff. You know, or you get a gain slope like this. You know, it's really, really good, and then all of a sudden, see you later. There's plenty of common parts out there that'll do it. Look at it, you know, nice, kind of flat. You know, you never thought about looking at that ever being an issue. And, you know, the output power is not bad. That might make a real good driver for something. This is a part we use in the 10 gigahertz transverter, but who'd have thought that it, you know, it's got a little hump down low, but it pretty much stays 10 dB gain all the way through the microwave region. It's just a real good part. And it is obsolete. But, of course, they're available. Because you have to make them available if you're going to use them for the rest of your life. All right, look at this bad boy. Small signal gain at 2 gigahertz. They just spec it. Broadband frequency range. High output 3. Right? 100 milliwatts. It's even in a SOT 89 package. This is Skyworks. Real simple circuit. That's all. Just like any other MMIC. Blocking capacitors, some kind of choke, and a current limiter. And look at that gain curve. And they stopped it at 5, though. And I don't know why they did that, because they should be pretty proud of what it does at 6 gigahertz. It's probably something we're going to be using. No, it hangs in there. It really does. That's why I said I don't even know why they stopped it. They should be bragging about it because of the way it actually behaves. And this low frequency stuff, you know, you can roll that off a little bit by just using a higher value DC blocking capacitor, which is, you know, the engineering trick. All right, so now a little bit more exotic stuff. Check this out. Anybody seen these? 1 watt, DC to 6. All these no connects on here. Why they waste this body, you know? I mean, they're not even ground. I mean, so they do nothing. They don't help with the cooling of it, anything, but they got a big pallet underneath, and it's a 5 millimeter by 5 millimeter square chip. It's a big one. You can actually hand solder this one. I sampled it and hand soldered, and it works just like this. It really does work just like that. Pretty amazing, ain't it? 13 dB gain from 0 to 8 gigahertz. Yeah, it gets wavy. It needs some matching up there, I'm sure, and you're going to lose the low end. But it's got something going on up there. But yeah, whatever that standard is, it didn't make any difference since we're both good. I didn't feel necessary to specify, but yeah, that's input and output return loss, and that's your gain. There you go. There's your PSAT. As you see what it does here, it crashes and burns here really fast. And 10 gigahertz, I think, would be around here, you know, big deal, 28 dBm. Yeah, you know. Again, someone else, they should be bragging about this a little bit more, and they're not. But here's the part they're bragging about. But think about it. How much money do you have in all your 1 watt transverters? Now, if you had one transverter that you dump this much into the output stage of it,
And the signal point of
well, and the signal point of failure, but you know, like if the transverter was cheap enough, you could always have a backup instead of having 8 separate bands that did 1 watt. So this is something we're seriously considering. And it's a possibility this was kind of a conservative number. It might be closer to $100. So power amplifier results. 100 milliwatts, no problem with the Skyworks part. 1 watt with the analog device part. And we got boards already laid out. Well, we got these patterns into our library already, and we've been fooling with them, placing them and pulling them out. And Sandra does all the PC board work. He's a mechanical engineer, so got to do that stuff. And we researched all these guys. We've taken a look at just about what everybody has to offer, you know, either through a sample or buying them through DigiKey because they're available. All right, let's talk about receive amplifiers. Same problem, same kind of issues, flatness, respectable noise figure, hand solderable type, preferred, but anybody take a look at some of the stuff we had on our table out there, like what we're doing on our 1296 transverter? Mimics are specified for wideband operation but require special tuning for optimization. Same problem with the power amplifiers. We want the same kind of gain level, same kind of gain slope. But this is now acceptable if they're not hand soldering. Let me show you why. Our 1296 board, transverter board, we did this as a, well, let's see if we can do it. This is a mini circuits part, this is the mini circuits part, a PMM 02 something. I can't remember these numbers. They're so crazy anymore. But that's 1 LNA and that's 2 LNAs. And if you notice this whole pattern here, the whole pattern's up here in the board. So we put studs up in the board. You pick the board up, you place it on the board. 2 pins go down and make contact with the circuitry. And this is your LNA input into the filter onto the next gain stage. And if you blow your first one out, you pick the second one up and you put it in place. I don't have to send you a part. You get 2 tries. It's all hand solderable. You just throw this away. If you want, you can send it to me. I can change these parts for you. You know, if you're really desperate for that third one that you need. Or if you want a backup, or we do have some backups. But, you know, the power module goes in here. So the board company, this is free. This just costs you the components. You know, this is free as far as the board goes. So you just do it. Well, yeah, we're also saying that, you know, but like, here's the other thing. We probably sold, we're probably pushing 100 of these now out the door. And we haven't released the kit yet because it's still a little cumbersome on the wiring. We're going to do a multi-layer board of this next rev. I haven't had anybody call back and say they need one in the ones that we built. No one has blown one out yet. Well, you start looking at the specs of these things, it takes about 100 milliwatts before they really start to compress. I mean, they got a real high input to start with. So unless they break down the isolation of the relay, or if they're running separate ports, they just do something dumb. Yeah, Bob, you want one?
I don't have one.
Yeah. I didn't want to point a couple of you guys out here. You know, it's kind of like patient-client privilege. You know, I don't.
You didn't mention the IP3 on these things and the fact that they've gotten so good they don't need the input filter as bad as they used to.
Oh, well, exactly, and that's the whole thing. So yeah, we're keeping a low noise. These things are half a dB noise figure at 1296. They do work up to 2 gigahertz, but they roll off pretty fast. And we picked this one in particular because it rolled off fast above that frequency. But yeah, we're just putting a filter on the output of it before we amplify it again. And we'll get to the filter part of this. But here's a close-up view of what one looks like on the board. And these are just straight pins like we put in the pipe cap filters. And I've had no matching problem. This is 031 FR4. And the total conversion gain is usually just a little bit over a dB when we get done with it, you know, through the mixer and everything. And a gain is, I mean, the noise figure is just a little over a dB, but the gain is 17, 18 dB gain on 1296 and a little higher on 900. And this board is both, either 900 or 1296. It was another little manufacturing feature we'll show you later on. But to give you a perspective of what these part sizes are like, no, don't get carried away, guys. This is a 3 by 3 mil filter. This is a 3 by 3 mil. So the actual part is, 2/3 of this that we're using, 2 mil by 2 mil. And there's chips out there that are 1.5 mil square with 8 leads on it and a bottom that you have to solder. Yeah. This is a 1206 chip resistor that everybody said, I don't like doing surface mount. Yeah. These are 0603s. These are little chip inductors. That's a 0402 chip resistor. Just to give you an idea, and President Roosevelt's really happy to hold them all for us. Oh yeah, this is the part, the PMA 2-33 LNA. So it's good to 3 gigahertz. But you can see this doesn't hold up for what we want to do it in a wideband transverter. But it was our first taste of what we can actually do with these parts. It was a worthwhile experiment that proved out. This is a part that we're putting in our LNA right now, the 1296 or 900 megahertz LNA. And these are real numbers. We have absolutely no problem duplicating those numbers. And that's with a filter on the output of it. Nothing. 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 And the LNA we make is either 900 or 1296. You select the filter you want to use on the board when you install it. And, of course, whoops, went the wrong way. That's the gain curve, and that's why we can't use it at 6 gigahertz. You can, but it's like, it makes it a little cumbersome. But lucky, you keep looking around. There's one here that's like way too hot. They say just use it 700 to 6, but yet they give you specs all the way down here, 30 dB gain, and 6 gigahertz is 15. But that gain slope is a little bit large, and there's a typical example of the 8 pins with a pallet, but still simple operation. And noise figures. This is your real noise figure here. And you just put them on a good low-loss circuit board and connector it up and rock and roll, man. So you keep looking, and then you find little quirks in the system. Why this little whoop-de-doo happens here, I have no idea, but it's real. And this was sampled to me for this in mind. This is really what they designed this part for. So they did something inside of this chip to knock this down here and optimize it here. So once they do that, then and talking to these guys at, I guess, did you pronounce that company? Is it Gorilla? Is that how they pronounce the name? Yeah. They said, well, we'll custom tune you anything you want. Just tell us. Everybody must be doing it. Here's a real good idea what the chip looks like. This is a 2 by 2 millimeter chip, solder pad, and these are the other 8 connections. And this one requires a little tuning to make it work like this here. So of course we don't want anything like that. There's this other little basic gain block. This is the second stage in our 1200 and 900 megahertz transverter, and you can see it holds up pretty good. And it starts to tail off here, but it's really simple. Noise figure is very reasonable. P1 dB is very reasonable. It's just not good enough for the high frequencies. Everybody's using these, right? How many? What's that? No. But how many guys are blowing these up? Yeah. They're a little loose, aren't they? I have no idea what happens to these things. They just get a bug up the wrong place and just leave us. But I mean, it's. I still haven't figured it out. They're just touchy. I would not recommend using them if you don't know what you're doing or if you don't expect problems. Another example of, we get a data sheet, well, you got to put this 1.5 nanohenry choke here, and you got to cut this strip line to do this, so like, this is just to get it to work at 900 megahertz. Nah, we ain't going to use that. Here's my favorite. Anybody here work at this company or know of this company? They're from, they're up in I think they're up in the Rochester, New York area, or Schenectady. Isn't that something? Look at that.
They must have back.
Look at this noise figure. All right? Well, just check it out, right? And it's like, so I said, well, this is pretty cool. And they sent us their sheet. We like, anymore, you get on there and say, I'm looking for this part. Next thing you know, we got everybody say, oh, you need this, you need this. I mean, like, it's anything anymore, from going on vacation or booking a hotel in a town. You start looking for parts like this, and everybody is like, I got just what you need. Well, I sort of thought so. I looked at this part. Look at this. This is half an inch. It's like 450 thousandths of an inch. We'll just solder this bad boy down, just 3 leads here. So I said, all right, Sandy, let's get the 11 to 15 volts. I mean, you can run this directly off of 12 volts. Yeah, there it is. There you go. Well, Sandy, get us a quote. And she says, okay. I said, tell them 100 piece quote. Let's get it. And so she came back to me and she says, well, see, 100 pieces, it's $939. I says, well, that's not bad. And she says, no, a piece. So as of today, we're starting the crowdsource. You can sign up with Sandra. Yeah, I guess it's worth that to somebody. But, that's 3 transverters as far as I'm concerned. It's like, it's a little over the top. So, but again, the stuff is there. It's like, so what really looks good? This one here is kind of good. This one holds up. This one holds up pretty good here above 5 gigahertz. We're looking at that, but again, and this is the latest one I'm looking at. I've just received samples on it. It's in the R&D department, so decent noise figure, decent gain. It's got a little whoop-de-doo in it, but we could probably work with something. And as I said, the only problem with this part right now, it's in the R&D department, so it's hard to say when it's going to. It's kind of nice with this 2.5 mil. We got a board that we can just drop these parts on now, and some of them need bias on one pin, some of them need on the other pin, but they're sort of like getting it straightened out. But anyway, so let's get back to the LNA results here. There's absolutely no issue if we wanted to do it to here. 5760 would be a compromise with gain and roll-off, and that's what gain and noise figure, and that's what we see right now. So that's the only thing that's got us teetering a little bit here. Some more research in there. And again, we looked at all these companies with what they had to offer to give us a part that will do this performance. All right, the important part. Everybody says, so what are you doing for filters now, Steve? VHF, UHF, helical type, surface mount needed, machine place, steep skirts required for microwave region, and of course, economics. Well, here we go. Everybody remembers the Tocos? Temwells. This was a Toco type. This was a ceramic type. And look at this little guy over here. We already seen a picture of that. It's a little saw filter that's sitting at 3 mil square, which seems to be an industry standard for them now. There's sitting alongside of there's a 1296 filter sitting alongside of a 1206 chip. This is the LNA board that we actually ran just to prove design concept out. This is the Corvo part, the 9037. I showed a data sheet that was good up to about 2 gigahertz. And this is, here you go, look at the numbers here. See, this has got a 9 on it, and this one's got a 6 on it. Well, that's the 1296 filter, and that's the 900 megahertz filter. They're backwards, but I think backwards a lot, so it's kind of easy for me. So with these guys here, you just come here, we put the miters on them, you just cut the line off here. And we realized after a while, well, we should just move the chip over here to pick one of these. But we had no idea how this was going to work, so we did this board, and They're 21 dB gain at 0.4 of a dB noise figure at 900 megahertz and half a dB noise figure and 18 dB gain at 1296. And that's through the filter loss. And I'll show you some of the filters. And as I said, in our transverter, that's what these are here, the same design we put on the transverter board.
Consider pin switching those filters, so you wouldn't have.
Well, and you see, that was the concept in the multiband when we were putting multiple filters in it. We were going to use pin switching, but that's the latest thing that just happened. But you know, in a small little design like that, you just move the chip one way or the other. You know, if you got two bands, and it just makes it really simple. The board's already cut; nobody has to like take a chance cutting the board. But there's your basic SAW filter, and this is like industry standard. Everybody's making them this way. Pin 1 or the A pin is always the largest, and that's your lineup pin. Just to give you an idea, that's N9. They already took the same one that we were using. So they do make them at low frequencies. There's 6 megahertz pass band. Look at that. It's a little scary looking. The low frequency stuff is still out of the IF world, but you know, the ones you find with a decent insertion loss, which is if you're looking at SAW filters, don't even bother looking at IF filters unless you really need to do an IF filter because they're 15, 20 dB insertion loss.
Good, they used to wait.
Yeah, I know, but you know, nowadays. Here's another one that works at 220 megahertz, same kind of performance. There you go. Here's your real pass band. You know, 3 dB loss. 433, they're already cut for frequency, ready to go. This is near that pattern, and you can find 70 centimeter filters that'll work at that pattern. But this is the 900 megahertz filter that we are using. Covers a whole band, but where's 880? There's 880 megahertz. That pesky cellular band stuff. Yep. And it really is. I mean, it's amazing how these things work. There's 1296 filter. And then we go on and on. 2304, 2320, you can get out of the same filter. And 2400, 2424. Are we still using 2424s in the EME band? Still being used?
Yeah, 2400.
Just 2400? Yeah, okay. At the time when I did this back in the spring, I thought 2424 was still important to people. Yeah. Yeah, okay. Well, you know, there's other stuff that we're doing with that. But basically, we got one filter that'll cover both with a 2-meter IF. 3400, we got to start looking at ceramic filters. No one's making a SAW filter yet that's going to really, it doesn't have a narrow enough pass band. But even these are relatively expensive compared to, you know, ceramic filters. They're somewhere around $5 a piece, and they are hand solderable. So for people who want 3400 or 3456, it might be just a selection of what filter you put on the board. Same pattern. 5760, that's in plain words, is a real hump. You know, you get this frequency range, you get this crazy bandwidth, you get, you know, some attenuation outside, you know, then they don't have it yet, and this is even in the ceramic filters. It's just not narrow enough. Which might say, well, you know, depends what you do with 5760, and we've sort of discussed what we're going to do with that later on. So filter results. No issues, 144 to 2400 with discrete at VHF. You know, 100 milliwatts, you can do a discrete filter. The only problem is the 5760. All right, local oscillator. We've already talked about this. The issue is, you know, 0 dB output, simple frequency selection. Whatever we can get our LO frequency on it. We've already chose what we're going to be using. The only issue with this version, if anybody's looked at this, of what the outputs are at 3 and 5 gigahertz, is that they start to roll off in power. So 5760 is probably like a minus 10 dBm output, but gain is cheap. It's just, well, how do you do it when you have to put it between your LO and your mixer when you don't want to overdrive at 900 megahertz? So we got no issues again, same kind of final results. far as we know, we could just whip this baby right out the door, tomorrow. It's ready to go, but we're trying to work what we're going to do with this. That's what's kind of like holding us up. So here's the new stuff, and I want you SDR guys to take a look at. RF switches. Has anybody seen these things? It's amazing. Here's an 8-pole, single pole, 8-throw switch. Drop it on the board. Yeah, well, don't ask Sandra.
I already heard.
You did, yeah. Well, we had this elaborate thing all laid out, and I actually put, pin diode, bias network, filter in between, 8 bands. So there's 16 pin diodes already laid out, and the bias resistors for every one, and the blocking capacitors, all this stuff, and now it gets replaced with, 1 part and 2 chip caps. But it's less parts, dear. Yeah. It's I'm actually doing the testing on this thing now. Just got it in before we left, so when I get home, I'm going to be sparking it up. Here's a real amazing switch. Well, that's the 60 insertion loss dB.5, but we don't care at this low level when we're just switching filters in and out. But it works already down here. And gain is cheap. Look at this bad boy. It's 5 millimeters square. Well, if you notice all the leads here also say, that's a really important part of the cooling. So I haven't gotten one of these yet, but someday when we run out of SMA relays, or where you're using this SMA relay in some stupid place in your system, where you could be putting it to good work somewhere else. Here's some insertion loss on it. I guess the black trace is the real one we want to look at. I don't know yet.
They should be. With no blocking caps, they're just fed switches, so they'll go down probably.
Yeah, I don't know yet. I'm waiting for it to arrive. And I got to do a new board. That's the only way I'm going to find out. I don't have a 5 mil square with that many pads on it in the house.
What's the isolation?
The isolation was phenomenal down to low frequency. I saw the worst case isolation about 35 dB at 10 gigahertz. I don't know if that's true. I'm sure it's going to depend on all kinds of circuit board layout at that frequency.
What was the price?
Oh, $2.50. I forgot that part.
Take 2, they're small.
Yeah. Everything I look at, if it's like $2 to $3, I'm interested, it's like, anything out of that range, I'm semi-interested.
900, not so much.
Yeah, 500, not so much, All right, so here's another little handy thing here. Now, I see you guys with your SDR radios, you got these ports coming out, and you got one port that does everything, and what do we want to do to bump up the power? And plus, we want to make LNA gain back. We want receiver gain. Well, I was sitting around one day in one of those nap sessions, and I realized that, this part does exist. And what is it? It's a low noise bypass amplifier, all right? So it's got a noise figure, all right, so it's a dB.5, but it's got this kind of a gain. And the very simple schematic, RF in, RF out, leave the voltage on it and cycle this thing on and off, and it either bypasses the LNA or not. And it's $2.50, right? Well, what if you did something like really crazy? I mean, like really, really crazy, and put 2 of them in line like this?
There you go, there's VR.
Now you don't need a relay. And you have nearly 100 milliwatts, and start looking at this. Output power compression, 100 milliwatts. And what kind of power can you pass through this in the bypass mode? Look at this. A watt of power going through it in the bypass mode. I mean, and it's $2.50.
Well, you got 2 of them. I got 5.
We have $5, okay. But I mean, so start thinking about the concept. You got this multiple frequency LO that's switching into this mixer, and on the output of this mixer, you got all these filters that you're selecting with a single output, and then you go into this. That makes your 100 milliwatt transverter, and you have a dB.5 noise figure to boot. Oh yeah, but again, we're talking about this. We're talking about this company that guarantees that their components will never go obsolete. I haven't had it happen now. Have you had it happen, Paul? Mini circuits? There you go. The custom ones you get free at Hamfest. Those are the ones that go obsolete. But if we get invested in something like this, there'll be 1,000 of these sitting on our shelf, before we even plant anything. And the lots will be checked, and all kinds of stuff. I don't want to say this happens to a lot of companies, but we've bought gas FETs that were nothing inside of them, not even connected input to output. They were just empty packages that somebody prepackaged and sold. So, you got to test this stuff. Yeah, it was either Monday morning or Friday afternoon. I don't know. It's like, it happens in Detroit, I understand. Why can't it happen elsewhere in this world? But, and there's a lot of companies that are making this stuff, and there's more companies that are coming out with other parts and other features. All right. Of course, we know who the team leader is. We know who the staff is. Yeah. Yeah, well, that's out of our tilapia pond. That's our hobby. Dinner. That was dinner, let me tell you. All right, so we come up with something that looks like this in a block diagram. Digi-LO, one mixer, transceiver IF switch, a little filter here, low pass filter. I have a 6-pole switch in here, and the boss put these 8 in here. This really should say 8 poles. And yeah, this was done when we had just had a TR switch, which is an option. We can still do that, or we can just do what we saw, that double LNA part in there. So this is, as far as we're concerned, the designs are near completion. All international satellite bands are included, 144 or 28 megahertz. We can do a 100 milliwatt, or we can do a 1 watt design. dB.5 noise figure are close. And we've come up with a scheme where we can do options for 10 and 24 gigahertz and 5 gigahertz if we can't make it work on the main board with a decent filter. All standard transverter filters, all SMD pre-assembled PC board, a machine aluminum enclosure. Somebody's seen some of our new CNC stuff we're doing out there. And band decoder switching with options. That's why I asked Mike about if they're going to standardize this stuff with band decoders, because that'll help embed that concept in everything that we do from now on. And I'm enthralled with the band decoder outputs, all these modern transceivers. I just use them for just about everything now. So we still got some decisions to make. Do we put a TR switch in the microwave transverters? Do we somehow do some kind of sequencer with it? And what do we do with the higher bands? Let's look at some schematic details so I can show you guys. Okay. We'll look at some schematic details. This is basically the schematic. This is the new RF switch with all the filters in it. This is the transmitter. This is the receiver. This is the IF section. This is where the LO comes in. This is an amplifier stage in the LO. This band decoder. This is lock detect signal for that. This is just control regulator and control stuff and switching circuits. So this stuff is really not that important. It's standard transverter stuff. This is what I want to talk about. LO level control. Well, I came up with this real clever idea. LO level in. If it's a low level or a high level, you either bypass it straight through or you put it through the bias network, which is a T attenuator. So you put a big gain stage in here that you need for 5760, and then you're going to want to attenuate it at the 900, 1296, and 2304 levels. That'll work. But then we look at bypassed LNAs. And that complication goes away. So this gets replaced with this, single chip, and the switch circuit. So again, as I said, we go home and we find something else new. And it's like, well, that's kind of dumb what we're doing. We can do it this way. And again, that's the chip circuitry, just in and out and turn it on or off, and it bypasses the amplifier or not. Of course, band decoder, that's whatever, band decoder du jour. All right, so here's a transverter that has no filters on it, no nothing on it. It just comes out of the mixer, and it goes out through a 8-band switch. You guys think that would be a useful thing to have? You can do a lot of stuff with that. You could select your own LO frequency, come up with your own IF frequency, and take whatever you get out of here and do your filter and amplification. So maybe we can somehow implement this on both boards or make it a sectional board or something. Satellite guys. How would you like a transmitter converter that had two 70 centimeters, 12 or 13 centimeters, 1268, 50, what's the satellite frequency at 5 gigs? 5850. Just by putting the right filters in here and coming out to a gain stage, 100 milliwatts for a satellite uplink. And of course, if you can do it in transmit, you can do it in receive, just reverse it. So that's another possibility. Just a matter of the person laying out the board, putting in a nice little aluminum enclosure. After you do it on the CNC machine, this is up in New Jersey. They don't allow this kind of technology in Live Oak, Florida. But that's my brother-in-law who runs our machine shop. He also provides some other services to some other amateur radio companies that we're all well aware of in this world. You can put your hand up, Terry. I had to take the picture. I couldn't get that close to the machine. I start touching stuff. But, you know, nice little box enclosure with multiple connectors on it and some kind of control connector. And the only thing you need after that is just a modest antenna system. High band options. So just like Mike brought out the 10 and 24 gigahertz piece, why not do the same thing? I mean, there's mixers. This mixer is like about $8. It got cheaper as it went up higher in frequency. So you bring one of those 8 ports, since you only need 7 bands, you bring the 8th port out, and you do the single LO scheme. So LO equals RF minus IF divided by multiplier plus 1. So you run everything at a 2808 megahertz LO, and you can split it out and run that frequency into a 5760, and they'll mix down into the same mix in the standard transverter. You can do that all the way up through 24 gigahertz without any problem. You just have to develop the multipliers and switch them. So if that was in a separate board with, you know, pipe caps on 5 and 10 gigahertz and some interdigital widget on 24 gigahertz, whatever you needed to get you there, and you run that into the a transmit piece, you'd be all right. And there's an LNA piece that's already ready to go. That frequency range, $45 at 100 pieces, 2.5 dB noise figure, 22 dB gain. That's 5 through 24 gigahertz. Here's your transmitter part. And again, yeah, that looks like it's a big number. But, you know, what do you got into your 5 and your 10 and your 24 gigahertz unit now? And it does a watt. And that's just a brief schematic of how you go about doing it. That would be a separate board, but, you know, filters, multipliers. It gets a little bit more elaborate as of now. And you wind up with your setup with just a computer and a K3, and you're operating everything from 6 meters through 24 gigahertz. And just happily, and I'm the guy that's sleeping outside taking that nap. All right. That's about it. Is there any questions? I didn't hear many questions during it. You're all enthralled. You're just like blown away, right?
Exactly. We're soaking it in.
I mean, it's just phenomenal. Yes, Tom. That's Tom, right? I got the wrong glasses on to see past John here.
Well, it depends on whether you're mad at me when I'm done with this. First off, Steve, I got to tell you, I'm really impressed with the effort you put into these things and the financial investment that goes into making these things possible for us. I think that's really worth a round of applause or something at some point.
Well, but first, you guys got to understand, everybody's got a job in this world, and it just so happens mine might be a little bit more fun than yours.
You're right, and I'm retired. Anyway, But the question that comes up to mind at this point is, okay, you've got a single input-output port, but you're talking a lot of bands, which means multiple power amplifiers and multiple antennas, right? So
Yeah, if you want to
so
get above the 1 watt level, yeah.
Right. So, but even if you don't, you've still got some kind of antenna switching, or you just manually switch it again, or what?
As some of that circuitry I showed over the side, there's auxiliary output, so you can switch anything with it. You know, drive an external relay to go to your,
Okay.
you know, your kilowatt amplifier and
The
2
decoder,
meters
yeah.
into your TWT on 24 gigahertz. That wouldn't
Okay.
make any difference.
Yeah.
Yeah, that's all taken into consideration. That's why the sequencing is a question for us. Is if we just had a single push-to-talk line coming out, it could drive a sequencer on any band that you're
Right.
running larger equipment on.
Right.
So, I mean, we're taking that all into consideration.
Super. Thank you.
Anybody else? I think you guys make it easy. Yes, where's the question? Hold it. They're bringing you a microphone so everybody can hear you.
It seems like everything you've got has been transverter-centric, but people have been introducing a lot of these SDR, wideband SDR boards. Have you thought about doing some type of SDR accessory?
Well, as you can see from the research we've done on these components, I will tell any SDR manufacturer, anybody that's dabbling with this, when you're ready to go where you can grab a microphone and talk into an SDR radio, or you can grab a CW key and carry on a conversation, we will have a LNA power amplifier unit for whatever band you want. It's just that simple. We have the ability to do it now. And with the components, it's just becoming more and more phenomenal. And of course, switching, I mean, you can make a multi-band device with all these little switches we got now. It just tag something on and you change bands on your SDR, you're changing bands to your power amplifier and LNA scheme at the same time.
When do you expect to be shipping product?
Well, you know, as I said, I'm going to go home and somebody else is going to send me, well, Steve, you haven't seen this yet, you know. And, you know, how many people have been in the job where it just doesn't finish because something else always changes? And finally the boss says, that's it.
Where are the engineers?
Yeah, that's it. That's it. That engineer will be doing this for the rest of his life if you let him.
Comes the time to shoot engineers.
Exactly. Well, I'm savvy enough that I have a mortgage to pay. So, you know, I got to get motivated, you know, some way to start making some money on this stuff. So it's just like any other job. It's a great job, and somebody has to do it. And I'm just lucky it's me. Well, yeah, that's... All right, thank you, everybody. If there's no more questions, thank you.
Thanks, Steve.